NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
In recent weeks, Voyager 1 experienced a sudden resurrection that many thought was impossible, as NASA's engineers somehow reactivated its backup thrusters that had stopped working since 2004.
Man-made object to reach interstellar space, the cold, dark region between stars, far from the influence of our sun. It actually happened last year, but NASA only confirmed the data on Thursday.
After 9 months of silence from corrupted transmission, Elon Musk now reveals that Voyager 1 is transmitting usable data once again, along with newer and more exciting discoveries on the terrifying mysteries of interstellar space.
This is the biggest, strangest mystery in all the universe at the present time.
Wow.
These are called fast radio bursts.
How was NASA able to revive worn-out parts that failed over 20 years ago? And what intriguing discoveries came after this? Join us as we unravel the magnificent return of Voyager 1.
I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
Voyager 1's resurrection. The early months of 2025 were a very difficult time for America's leading agency. Not only was NASA struggling with too many technical setbacks, but a constant lack of funding from the ever-changing government administrations wasn't helping either. Many projects suffered because of this. For one, the Artemis program that promised to send mankind back to the moon with help from SpaceX was postponed indefinitely. This happened because the money and resources from both sides were barely enough to cover all aspects of their ambitious project. But worse yet, the current administration had slashed NASA's funding by 24%. with a 53% cut to space and Earth missions. This effectively canceled important projects for 2026, like the Mars Sample Return and the Macy Grace Roman Space Telescope, unintentionally leading to the loss of over 5,000 jobs across various centers. But the problems didn't stop there. NASA's engineers were on a race against time with Voyager 1. The machine was in a very critical state, with lingering issues dating back to a major error found that had been unresolved since late 2023. This critical error was detected by Linda Spilker, an American senior planetary scientist at NASA's Jet Propulsion Laboratory in California. You won't believe the readings she got from the spacecraft. The transmission received from the spacecraft's flight data subsystem, in charge of organizing and transmitting info back to Earth, was now sending randomized binary code instead of usable readings. What were these jumbled readings all about? Was this just readable information rendered useless by natural cosmic interference along the way? Or was it something even more exciting? Well, the answer lies in how Voyager 1 works. For one, keep in mind that the spacecraft at this point was at a distance that takes light almost an entire day to reach. At highway speeds, this would take almost 20 million years of endless travel to reach. And for the signal to be successful, the data transmitted requires at least 23 watts of power. This is the same amount of power it takes to keep a dim bulb turned on. This very weak signal makes things very difficult, because the sheer distance alone would make its strength up to 20 billion times weaker than the battery in an old wristwatch by the time it reaches Earth. To capture these incredibly weak signals with maximum efficiency, NASA's Deep Space Network uses 230-foot radio dishes operating in 3 facilities, one in California, another in Spain, and the last in Australia. These 3 places were chosen because of how evenly distant they are from each other, making sure that the network keeps working as the Earth rotates. Each of these facilities can detect signals as weak as 1/1000th of a watt. And while these numbers seem to bend the brain, the challenges they implied were even more difficult to deal with now that the machine they built all these stations for wasn't working properly anymore. Since 2012, Voyager 1 has crossed the boundaries of our solar system and ventured into interstellar space, a void region between various solar systems. This happened in August of that year, and that was when it started relaying information about what the universe was like outside our solar system. This was so important because the data it collects cannot be obtained by any other means. After all, no telescope can detect the environmental conditions out there. While our most powerful telescopes detected large planets in the furthest reaches of our galaxy, things like particle densities, magnetic field strengths, and plasma conditions beyond the heliosphere can only be detected by the Voyager spacecraft. The difficult reality for today's engineers at NASA is that the machine was built with very outdated tools. For one, Voyager 1 runs on just 69 kilobytes of RAM, That's right, way less than the memory occupied by a single text message on your smartphone. Most of the engineers who designed these systems have either retired or died, leaving the current teams at NASA struggling to put up with 50-year-old documentation and inherited knowledge of how the spacecraft works. With every diagnostic command sent to Voyager, one taking almost an entire day to arrive, a simple status can take over 2 days, while assigning the simplest functions can take weeks. Think of it as taking an entire month just to flip an on and off switch in your living room. Operating Voyager 1 felt that way, except a whole lot more frustrating. You see, the flight data subsystem failure meant the spacecraft could no longer prepare data for transmission anymore. On paper, Voyager 1 has 11 scientific instruments that rely on the functioning computer system, and this was the part on the verge of permanent failure. As for the power supply, it comes from 3 radioisotope thermoelectric generators with plutonium-238. As the radioactive material breaks down, it produces the electricity needed to keep the machine running. But like every other power source, the amount of energy it gives out slowly decreases over time. And in Voyager 1's case, it was by 4 watts every year as the plutonium power source slowly broke down. This problem lingered for months, so much so that by March 2025, NASA's Deep Space Network planned to shut down its Australian command center. The idea was to upgrade the facilities to accommodate the much weaker signals received from Voyager 1 in recent weeks, limiting the global command capabilities until February 2026. During this time, the future of NASA was looking grim, but there was a glimmer of hope on the horizon. While the job was to simply keep Voyager in check until February 2026, engineers at NASA's Jet Propulsion Laboratory in California saw this as a chance to re-establish proper control of the spacecraft. For them, that meant sending a strong command to Voyager 1 to change its trajectory through its hydrazine propulsion thrusters. But this was highly unlikely due to how long it had been since anyone had tried sending such a command. The last time a command like this was sent was in 2004, and the reason no one ever did that again was because the thrusters weren't working anymore after over 25 years of being functional in space. There was no reason to believe this wild command would work. This is mainly because ever since the thrusters stopped working in 2004, the leftover hydrazine fuel in the primary altitude control system naturally creates clogged byproducts over the narrow valves. These clogged valves cause a weaker impact even from the strongest of thrusts, resulting in bad orientation adjustments for Voyager 1. This was a huge factor since the spacecraft has a very narrow beam pointed in Earth's direction. But that's not all. Any small change in its pointing accuracy can make communication a nightmare for engineers trying to decide the signals. What makes this breakthrough even more intriguing is that these thrusters were never built to be used almost 50 years later in the far reaches of interstellar space. They stopped working after Voyager 1 went past the gas giants and started heading towards the edge of the heliosphere. Bringing them back online at this point was regarded as impossible. To do this, there would need to be a full system analysis based on much clearer signals that are more advanced than anything tech from the 70s can afford today. There would also need to be multiple software patches, memory relocation, and command sequencing just to get things up and running. Simply put, this was an impossible task. However, the engineers in charge of keeping watch over Voyager during this offline period decided to take their chance. So in late April, they sent the reactivation sequence for the hydrazine thrusters, and the successful telemetry confirming the success of this reactivation occurred on May 4th. And just like that, NASA's Voyager mission operations team achieved the impossible. Somehow, they had managed to reactivate long-dead spacecraft thrusters over 15 billion miles from Earth. These thrusters were responsible for roll control and spacecraft orientation, but couldn't be restarted in 2004. It was regarded as a critical part of the machine that degraded naturally along the way. It hadn't been used in over 21 years, and their restart marked the first time these parts of Voyager 1 were ever brought up as a point of discussion in the scientific community. Thanks to this, Voyager 1's pointing systems have now been stabilized. This successful maneuver was never planned as a backup from the start, yet somehow NASA was able to pull this off with our modern tools operating on an old spacecraft machine with just 69 kilobytes of RAM and over 10 million miles away from Earth. The backup thrusters they reactivated were first used during the first planetary encounters with the gas giants way back in 1979, and they were used for very specific purposes, These good old days of the late 70s and 80s were perhaps the peak of Voyager 1's incredible journey through the heavens. It didn't do this alone, as another spacecraft called Voyager 2 was launched with the same mission in mind. So stay with us as we go on a trip back in time to when this happened and how it shaped our understanding of how the universe works. Exploring Jupiter and Saturn. As Voyager 1 started its fly by Jupiter, it began transmitting stunning images back to Earth. These weren't just blurry photos of a distant world. They were intricate, high-resolution images for the time that showed Jupiter's swirling cloud atmosphere in detail. The famous Great Red Spot, a storm larger than Earth that has been raging for centuries, was seen like never before, revealing a complex tapestry of swirling clouds and dynamic weather systems. Scientists marveled at the vibrant colors and patterns, reminiscent of a painter's brushstrokes on a massive cosmic canvas. But the most astonishing revelation was yet to come. As the Voyagers continued their journey, they turned their cameras towards Jupiter's enigmatic moons. Among them was Io, a moon that would soon astonish the world. The images revealed active volcanoes spewing lava and volcanic plumes erupting high above their surface. This discovery was groundbreaking, as it was the first time any form of active volcanic activity was spotted beyond Earth. Io's fiery landscape was an existing proof of the immense gravitational forces exerted by Jupiter, which always generates heat and drives the lunar surface to natural insanity. This completely changed our understanding of Io. The exploration of Jupiter's moons didn't stop with Io, and it continued with the Voyagers capturing images of Europa, Ganymede, and Callisto, each presenting a world of its own. Europa's icy surface hinted at the possibility of a subsurface ocean, raising interest in its potential for harboring life. Ganymede, the largest moon in the solar system, showed a very complex surface with diverse geological features, while Callisto's ancient, heavily cratered landscape told a story of its own. Beyond the moons, the Voyagers delved into Jupiter's powerful magnetosphere, the largest in the solar system. Voyagers 1 and 2 provided insights into their structure and dynamics, revealing how they interact with the solar wind and the surrounding space environment. This information helps scientists piece together the puzzle of Jupiter's magnetic field and its influence on the solar system. The first encounter with Jupiter by the Voyagers was a journey of discovery that captivated the world. The images and data returned by these intrepid spacecraft expanded our knowledge of the solar system and set the stage for future missions to the gas giant. In the early 1980s, the Voyager missions gave humanity an extraordinary glimpse of Saturn, the crown jewel of our solar system. With its stunning rings and mysterious moons, Saturn had always been a planet of intrigue, but Voyager 1 and 2 did transform our understanding of this distant world. These spacecraft, like cosmic explorers, embarked on a journey to Saturn, revealing its secrets in a way never before imagined. As Voyager 1 flew by Saturn in November 1980, it sent back images that left scientists and the public in awe. For the first time, we saw Saturn's rings in unprecedented detail. What once appeared as a simple band of light through telescopes was now a complex structure of countless icy particles, each orbiting the planet in perfect harmony. The rings were divided into intricate patterns and divisions, with gaps that hinted at the presence of tiny moonlets, shepherding the particles along their paths. The images captured the shimmering beauty of these rings, reflecting sunlight like a cosmic jewel box. Voyager 2 followed in unveiling Saturn's mysteries. It discovered several new moons, each with its own unique characteristics. Among these was the moon Enceladus, which would later become a focal point for astrobiologists due to its geysers spewing icy particles into space. This hinted at the possibility of subsurface oceans beneath its icy crust, raising questions about the potential for life beyond Earth. The Voyagers didn't stop at just photographing Saturn's rings and moons. They also provided insights into the planet's atmosphere, a swirling mass of clouds and storms, some of which dwarfed even the largest hurricanes on Earth. The images revealed the enigmatic hexagonal storm at Saturn's North Pole, a feature that continues to fascinate scientists. The data gathered helped us understand the dynamics of gas giant atmospheres and offered clues to the planet's complex weather patterns. It probed Saturn's magnetic field, discovering that it is unique among the planets in our solar system. Its magnetic axis is nearly perfectly aligned with its rotational axis, a phenomenon not observed anywhere else. This finding deepened our understanding of planetary magnetism and its effects on surrounding space environments. The first encounters with Saturn by Voyagers 1 and 2 were monumental, showing a portrait of a planet that had long captivated the human imagination. But things were about to get even more interesting. Exploring Uranus and Neptune. Far beyond the orbit of Saturn lie the enigmatic ice giants Uranus and Neptune. These distant worlds, cloaked in mystery and curiosity, were visited by Voyager 2 in a daring journey that remains unmatched in the annals of space exploration. In 1986 and 1989, Voyager 2 achieved what no other spacecraft has done since. It provided humanity with our first and only up-close encounters with these frozen realms, unveiling secrets that had eluded us for centuries. The adventure began with Uranus in January 1986. When Voyager 2 approached this distant planet, it revealed a world unlike any other. Uranus, with its serene blue-green hue, appeared almost featureless at first glance, but closer inspection revealed a planet tipped on its side, rolling around the sun like a barrel. This peculiar tilt, likely the result of a cataclysmic collision, sparked curiosity about the planet's history and evolution. The spacecraft's cameras captured images of Uranus's delicate ring system, composed of dark, narrow bands encircling the planet, previously unseen by earthly telescopes. But the true marvel lay in the moons of Uranus. Voyager 2 discovered 10 new moons, each with its own story to tell. Among them, Miranda stood out with its bizarre, patchwork surface, a mosaic of cliffs and valleys that suggested a tumultuous past of maybe geological upheaval. 3 years later, Voyager 2 delved into Neptune, the final planet in our solar system, in August 1989. As it approached, Neptune emerged from the darkness, a deep azure world, swirling with powerful storms. Among these was the Great Dark Spot, a massive tempest akin to Jupiter's Great Red Spot, showing the fierce atmospheric dynamics at play on this distant giant. Voyager 2's instruments recorded wind speeds of over 1,200 miles per hour. This is the fastest wind speed in the solar system, revealing Neptune as a planet of untamed weather. Neptune's moon Triton captured the spotlight with its icy geysers, spewing nitrogen gas into space, a sign of active geology on this frigid moon. Triton's surface, resembling a cantaloupe, hinted at a complex history of volcanic and tectonic activity. Voyager 2's close encounter with Triton offered tantalizing clues about the potential for geological processes on icy bodies far from the Sun. Voyager 2's historic flybys of Uranus and Neptune were more than just milestones in space exploration. They were odysseys of discovery that expanded our view of the solar system. These encounters provided a treasure of data about the ice giants, enriching our understanding of planetary formation. The journeys of the Voyager spacecraft were not just missions to distant planets, but were grand journeys into the unknown, revealing wonders and mysteries. Among the many groundbreaking discoveries made by Voyagers 1 and 2 was the identification of 23 new moons orbiting the outer planets. Okay, that was actually mind-blowing and unbelievable. The Voyagers ventured into the vast expanse of the outer solar system. They encountered worlds that had long been shrouded in mystery. In Jupiter, the Voyagers discovered 3 new moons around this gas giant, each one a unique piece in the intricate tapestry of its planetary system. These moons, with their diverse landscapes and characteristics, provided new insights into the processes shaping the Jovian environment. It didn't end there. The discoveries continued as the Voyagers went further, encountering Saturn and its spectacular rings. The spacecraft revealed 8 new moons around Saturn. Some of these moons were tiny, shepherding Saturn's rings and maintaining their delicate balance, while others hinted at complex geological histories. These findings painted a picture of Saturn as a dynamic system, teeming with celestial bodies of all sizes and shapes. Perhaps the most unexpected revelations came as Voyager 2 ventured to the distant realms of Uranus and Neptune, planets that had remained largely mysterious until the spacecraft's arrival. Uranus, with its serenity, was found to be surrounded by 10 new moons, each contributing to the intrigue of this icy giant. Among them was Miranda, a moon with a surface so bizarre it appeared to be stitched together from different parts, revealing a history of immense geological upheaval. At Neptune, Voyager 2 discovered 2 additional moons, orbiting this remote ice giant in the far reaches of our solar system. One of these moons, Proteus, emerged as one of the darkest bodies in the solar system, reflecting only a tiny fraction of sunlight. These discoveries at Neptune added to the growing realization that the outer planets were more complex and diverse than ever imagined. In the adventure of space exploration, some discoveries have been dramatic and fascinating, like the detection of active volcanism on Io, one of Jupiter's moons. When the Voyager spacecraft approached this tiny world, scientists had anticipated a cold, inert body, typical of many moons in the outer solar system. Instead, what they found was a fiery landscape of explosive activity that shattered all previous assumptions about geological processes beyond Earth. As Voyager 1 approached Io, its cameras captured images that were nothing short of astonishing. Plumes of sulfurous gases and molten rock were seen erupting from the surface, soaring hundreds of kilometers into space. This discovery was nothing short of revolutionary. It was the first time active volcanoes had been observed on another celestial body, proving that geological activity is not unique to Earth. Io's surface was revealed to be a vibrant tapestry of volcanic plains, lava lakes, and massive calderas, constantly reshaped by intense volcanic activity. The implications of this finding were profound. Io's intense volcanism was driven by powerful tidal forces exerted by Jupiter's immense gravity, which caused the moon's interior to flex and heat up. This process, known as tidal heating, explained Io's continuous and vigorous geological activity. The discovery of such a mechanism expanded our understanding of how moons and planets could generate internal heat and sustain active geology without relying solely on the decay of radioactive elements, as is the case with Earth. This groundbreaking revelation opened new avenues of exploration and inquiry, prompting scientists to reconsider the potential for geological processes on other moons and planets. It sparked questions about the role of tidal forces in shaping the evolution of celestial bodies across the solar system. Io's active volcanism provided a natural laboratory for studying volcanic processes in conditions vastly different from those on Earth, offering insights into the dynamics of molten rock and volcanic gases. The detection of active volcanism on Io was not just a scientific triumph, but a story that captured the imagination. It painted a picture of a solar system teeming with dynamic processes and reminded us that even in the farthest reaches of space, there are worlds as lively and unpredictable as our own. But what was even more profound was the time when Voyager 1 crossed into interstellar space in 2012. It was a journey over 3 decades in the making, a silent expedition that took this intrepid spacecraft beyond the boundaries of our solar system and into the vast unknown. Voyager 2 followed suit in 2018, marking humanity's second foray into the interstellar realm. These milestones were not just scientific achievements. They were defining moments in our quest to explore the cosmos, pushing the limits of what was thought possible and expanding the frontiers of human presence in the universe. The crossing into interstellar space was not marked by a single dramatic event, but by subtle changes in the data beaming back to Earth. As Voyager 1 ventured further from the Sun, it began to detect a decrease in solar particles and an increase in cosmic rays, high-energy particles originating from outside our solar system. These shifts signaled that the spacecraft had passed beyond the heliosphere, the vast bubble of charged particles and magnetic fields generated by the Sun. Voyager 2, taking a different path, confirmed this transition 6 years later, providing additional data and perspectives on this very dangerous frontier. Like some people, you might be asking, what makes it so dangerous? Stay tuned as we slowly unveil the terrors of interstellar space. Voyager 1's incredibly dangerous journey in interstellar space. One terrifying thing that causes NASA's scientists to be most concerned for Voyager 1, besides its natural death, are the ghosts of the early universe known as primordial black holes. These remnants of the Big Bang are formed by changes in density dating back over 10 billion years ago. These black holes could be as small as subatomic grains to massive objects over 1,000 times heavier than our Sun. Unlike the black holes formed from dying stars, these primordial ones give no light and sound. What's worse, depending on how large it is, the primordial black might never get detected by our current systems. One could easily pass through our solar system without warning, quickly swallowing everything in its path undetected. They could be everywhere for all we know, lurking in the dark within stars and rewriting the laws of physics as they move. A primordial black hole the size of a mountain could easily rip a minor planet apart within seconds and completely destroy our biggest and most advanced spacecraft. The much larger ones wander through space in ways we cannot detect. In fact, leading astrophysicists show real fear and awe for these frightening ghosts from the Big Bang. Neil deGrasse Tyson, for example, has described these hidden monsters as the universe's most terrifying sleeper agents. The famous astrophysicist notes that these objects might be the explanation behind the nature and origins of dark matter. Lawrence Krauss, a famous theoretical physicist, paints it in an even more ominous way by claiming these black holes could change the future of the universe on a whim. If there were any such thing as fate, these cosmic killing machines would have to be the cause. Our best AI simulations imply that these things outnumber stars by billions to one, showing that these deadly gravitational predators are scattered throughout every cubic meter of space. A famous science writer named Michio Kaku takes things a step further through his brilliant work on this topic that implies the smallest black holes might be responsible for cosmic disintegration. He states that some of the smallest microscopic black holes could be in your body right now, and some believe this might be the direct cause of unpleasant things like sudden death, unexplained illness, and entropy. But while this hasn't been confirmed, the final papers published by Stephen Hawking imply that while the smallest black holes going back to the Big Bang should have evaporated by now, the ones that have grown to the size of asteroids should be powerful enough to end our solar system by simply passing through as a visitor from interstellar space. Brian Cox, a particle physicist, believes primordial black holes were built into the universe immediately after the Big Bang to clean up after it. He calls them the cleanup crew of the universe, believing that as trillions of stars slowly stop forming and the physical world runs out of energy, these tiny black holes will grow and dominate all reality. Slowly but surely, they would consume all matter over trillions of years by devouring everything in their path. Sir Roger Penrose had even more frightening things to say about primordial black holes. When asked about it during an interview, the Nobel Prize winner said that these black holes might be responsible for why many experts aren't fully sure about the age of the universe. According to him, these black holes gave the power to increase the universe's entropy in a way that fast-forwards the natural aging process of the physical world. This means the universe might be a lot younger than we think, and might end much faster than we realize. Sean Carroll, the famous Caltech cosmologist, adds to this by saying these black holes could be changing the nature of the cosmos without leaving any trace of its work that we can detect. They are likely the chase behind galactic halos, galaxies suddenly merging at impossible speeds to destroy one another, and the strange clustering patterns observed in stars that shouldn't be within close range. Some think clusters like the Orion and the Pleiades align in strange patterns mainly because of these black holes. Finally, Alan Guth, the expert who developed inflation theory, believed that primordial black holes might be the reason why there aren't too many solar systems and planets with the right conditions for life to flourish as we have on Earth. As far as he is concerned, life on our planet exists simply because our cosmic neighborhood was lucky enough not to experience the disruption caused by these monsters of gravity. Other solar systems weren't so lucky, as the passage of a single black hole of this kind could mean the absence of life for billions of years. So, what do you think? Are there many more exciting discoveries yet to come, or should we keep counting down to Voyager 1's natural demise? Let us know in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on your screen. You will enjoy it.